Okay, so the last part of this that we're going to talk about, and I just have a couple questions that we're going to go through on this, but we're going to be talking about angles of elevation and angles of depression. Okay, the reason that trig is one thing that I want to go over, yes, because it's what we are. It's going to be on the ACT, but honestly, guys, trig is one of the most applicable things that you guys can use in your lifetime. I have a buddy works on pivots up in Nebraska at Reinke, and he has sent me pictures, and I wish I would have saved them, but of him just working with trig triangles. Him just working with trig triangles all the time, helping him to figure out distances, how far things are, because sometimes you don't have tape measures that go that far. Sometimes you can't get tape measures up that high. Okay, so the most practical part of what we're doing today is going to involve angles of elevation and depression. Okay, they're essentially the same thing. It just varies on where our eyes are looking. So let's say that we have this person down here, and this person down here is looking at a tree. Okay, well, if he was looking straight ahead, okay, that's going to be his line of sight, his normal line of sight. The angle of elevation is going to say, okay, let's say instead of him looking straight ahead, let's say he's looking straight up at the top of this tree. Okay, this right here, that angle is your angle of elevation. So the angle of elevation is going to be somebody looking up, and it's going to be comparative to, okay, if they were looking straight ahead, it'd be like this. So what's the angle when they are looking straight up? And what we can do is we can use that knowledge to figure out what this opposite side is, so we can figure out how tall that tree is. Okay, now if you guys will notice on your notes, I'm pretty sure I copied this incorrectly, but you guys can see from my picture here, you would also have to take into account how high up off the ground this guy's eyes are. Okay, but this angle right here will be our angle of elevation. Okay, so elevation is up. If we're talking about depression, okay, that's going to be the opposite. You've got your hornet here. There's his normal line of sight. Well, his angle of depression is going to be him looking down. Okay, so this right here would be your angle of depression. Okay, and just like before, let's say you know a distance as far as this goes, how far away it is from the base, but you don't know how high up the cliff is. Okay, well, you can use this triangle that you've created to figure out that distance as far as how high up you are on that cliff. Okay, so these are our angles of elevation, angles of depression, and that's kind of our vocab that we're going to need to go over these next few problems here. Okay, now the biggest thing for these next two problems is you guys have to draw a picture, and I put that on your homework assignment, but make sure that you guys are drawing a picture here. Okay, so it says the top of Cape Hatteras Lighthouse on the coast of North Carolina is 187 feet above sea level. Okay, so there's an important information, right? 187 feet above sea level. The angle of elevation from the boat to the top of the lighthouse is 31. Angle of elevation from the boat to the top of the lighthouse is 81 degrees. So that means we're going to be looking up at something, right? And this is actually what people will do with ships. They use lighthouses, okay, and they figure out how far away they are from the lighthouse, or they use them to figure out how far away they are from the lighthouse. Okay, so we need to draw a picture of this situation here. So for our picture, you guys have a boat, and that boat is out on the water. Okay, and that boat is approaching a lighthouse. So real quick, draw a picture of a lighthouse and draw a picture of a boat. Okay, and I'm not trying to brag, but I'm pretty good at drawing lighthouses and boats. Okay, so boom, there's my lighthouse. Okay, see if you can draw a better one than that. Okay, and then we also have our boat. And our boat is out there at sea. Okay, again, I don't know that many of you can draw a better boat than me. Okay, now we have our lighthouse, and I know that my lighthouse is 187 feet, right? And I know that there's a guy on this boat sitting out here, and he was using his angle of elevation. Angle of elevation, remember, is straight out, and it's the elevation of them looking up. Okay, it's the elevation of them looking up. Okay, and they're trying to figure out how far away they are. How far is this boat from the lighthouse? Because they want to make sure they don't run into the shore. Okay, so we draw our diagram first. So there's our diagram. Okay, you guys have your boat. The lighthouse is 187 feet tall. We're trying to figure out how far away it is. Okay? So honestly, the only new part with this lesson is drawing the picture. Okay? We've got our picture up there now, so we're good to go. Okay? So now I need to find my x. So now I'm just going back to what I did on that the first video for this lesson. Okay? What do I know about this triangle? What do I know about this triangle? Well, we need to identify everything. That is opposite of my angle. Opposite my 90-degree angle is my hypotenuse, which means that this part left is my adjacent. Okay? So I know my opposite, and I know an angle. What do I need to know? What do I need to know here? Well, I'm looking for my x, which my x is my adjacent side. So if you guys see opposite and adjacent, what's trig function am I going to use? So, TOA. TOA has the O and the A. TOA has the O and the A. So I'm going to need to use my tangent theta equals opposite over adjacent. Okay, I'm going to fill in my information. So I've got tangent of 31 equals my opposite is 187 feet, and my adjacent we don't know. Okay, x on the bottom. X on the bottom. Remember, with the x on the bottom, we can use that little trick. If the x is on the bottom, these two just switch spots. That gives me x equals 187 over tangent of 31. X equals 187 over tangent of 31. So I'm going to go through then, use my online calculator again. 187 over tangent of 31. Press enter, and they are 311 feet away. I went ahead and rounded to the nearest foot like it said. So that boat is 311 feet away. Wrong button. Fix it. So x equals 311 feet away. Now, some of you guys might be thinking, because I had made that big deal about making sure that we paid attention to how tall something was. If you guys are talking about 187 feet, a 5-foot person, a 6-foot person, that's kind of small money in the bucket on that part there. So you don't necessarily have to pay attention to that, especially if when you guys are looking at the problem and it doesn't say anything about the person that's doing it. Okay, so like for this problem here, it just said there's a boat. It said that it's 187 feet tall. It didn't say anything about the height of anybody. So we don't need to worry about the height for a problem like that. Okay, so let's do one more example then. Okay, got to click through all this stuff. So one more example. Okay, it says the Hamilton Hornet just pushed the Lawson Cardinal off a cliff. The Hornet is looking at the Cardinal with an angle of depression. Angle of depression. So remember, that means it's going down. Angle of depression of 71 degrees. The Cardinal is 25 feet from the base of the cliff. How high is the cliff if the Hornet stands at 6 foot? Okay, so this is what I was talking about on the last slide. I specifically told you, hey, the Hornet is 6 foot tall. So since I specifically told you the Hornet is 6 foot tall, then we have to worry about the height. The last problem didn't say anything about the height, so we don't have to worry about it. Okay? All right, so what I want you guys to do right now is I want you guys to pause, okay, and draw this picture. A Hornet has just pushed a Cardinal off the cliff. The Hornet is looking down at the Cardinal with an angle of depression of 71 degrees. The Cardinal is 25 feet from the base of the cliff. So real quick, draw a situation. Pause the video, draw this situation. Okay, hopefully you've paused the video. Hopefully you've drawn your Cardinal there. I want you guys to know I'm pretty proud of this animation, so I'm kind of bummed that you guys don't get to be here to see it, but we'll go through it here real quick. So you have your cliff, okay, and then your Hornet walks up to the cliff, and then after he walks up to the cliff, he sees that Cardinal, he gives him a little shove, and he pushes him off the cliff, where he promptly is not there anymore. So I'm going to draw my picture here, and I'm going to draw this incorrectly first to show you guys. Okay, a lot of you guys probably drew your picture like this because you're like, hey, they told us that's 25 feet. And that is incorrect. And the reason that is incorrect is because it says right up here that this is an angle of depression. Okay, angle of depression means comparative to somebody looking straight out, their normal line of sight, down. Okay, it's their normal line of sight and then down. So the blue triangle is correct. Okay, the blue triangle is what's correct. Okay, so when you guys do this, that needs to be your triangle there. Okay, now if the cardinal is 25 feet from the base, you guys are not wrong. You're not wrong that this distance is 25 feet. Okay, but you simply need to move this distance that you've found up. So that just tells us that that distance right there up top is 25 feet. That distance up top is 25 feet. And we were trying to figure out how tall the cliff is, how high the cliff is. So our x is going to be on this opposite side over here. Okay? All right, now remember, we need to identify our known information. What do we know about this? Okay, so we're going to go through. Opposite, that's my 90-degree angle. I didn't put it there, so that means that's my hypotenuse. Okay, and then my adjacent side is what's left over. Okay, so what do I know about this triangle? Well, I know the adjacent, and along with the adjacent, I know my angle, which I just realized I never filled in. It said our angle was 71 degrees. That's my fault. Angle was 71 degrees. Okay, what do I need to know on this one? Got my known. What do I need to know? Well, I need my opposite side. So again, opposite and adjacent, opposite and adjacent. Oa, Oa, SOHCAHTOA. Okay, so we're going to need to use our tangent. Theta equals my opposite over my adjacent. Okay, remember your theta is your angle measure, so this becomes tangent of 71 equals opposite. I don't know what my opposite is, but my adjacent is 25. Okay, last problem we went over what to do if the x was on the bottom. Now I've switched it, x is on top. Remember, x on top is the one that's a lot easier to solve. Okay, we're trying to get rid of that 25. Multiply by 25. Those cancel. Okay, but that means I have to multiply by 25 on the other side as well. Okay, I'm going to go to my Desmos calculator. Oops, there's the answer. And I'm going to take 25 times the tangent of 71. And it tells me that that cliff is 72.6. 72.6 tall. 72.6 tall. So, that tells me that x is 72.6. It doesn't tell me what's around, so I'm just going to do 72.6. Okay, now, don't forget there was an additional piece of information here. The Hornet stands at 6 feet tall. I'm going to go ahead and get my picture back up there. Sorry, guys. Okay, so since the Hornet stands at 6 feet tall, here's the top of our Hornet, right? There's the bottom of our Hornet. Does everybody agree with that? Now we found that x was 72.6. So we found that this distance right here, x, we found that that was 72.6. But we know that this distance right there is 6. Okay? So I'm trying to figure out the base or the top of the cliff to the bottom of the cliff. So the whole thing, this whole thing here was 72.6. We've got to take away 6 of it because that's how tall the Hornet was. So 72.6 minus 6 is going to give me 66.6 feet tall. Okay, rounded up to 67, which is what I did before. All right, 4 questions of these on the back of your guys' homework. Draw your pictures. You have to draw your pictures. You have to draw your pictures. Okay, again, if you guys have questions on anything, feel free to email me. Okay, I'll shoot you guys back an email. We'll get this all figured out. All right?